All primary raw materials and energy originate from nature. The process industry converts these raw materials into feasible raw materials for the manufacturing industry. This is done in facilities like mines, concentrators, refineries, and smelters. The process industry produce products such as metals, chemicals, and electricity. These are used by the manufacturing industry to create products that are used by consumers, like laptops, for example. Usually the process industry converts and refines not only primary materials from nature, but also secondary raw materials back to pure metals and chemicals. The recycling disposal ratio is a key performance indicator of the circular economy and sustainability. Metal producers have been pioneers in material and energy recycling. The very same iron, copper, and gold, which are produced hundreds and thousands of years ago, are still present in our buildings, cars, phones, because most of the metals are recycled in the metal production chain. Process model-based LCA rises the long metal recycling traditions based on common sense to a new level and converts qualitative estimates into real environmental footprint figures. The process industry has a key role in recycling. The environmental footprints of raw materials used by the manufacturing industry are determined by process industry. The environmental footprint can be evaluated via life cycle assessment or LCA. The LCA results depend on the production technology, specifics of raw materials, and site location. For example, the environmental footprint of electricity depends very much on the production technology. The same is true for the metals. The production technology, raw materials type, and location have huge impact on the environmental footprint of metals. For example, the footprint of gold is much smaller if the gold is made from copper production waste rather than from primary mining of gold. The LCA values of metals are not fundamental constants, even if many sources give this kind of impression. Usually in traditional life cycle analysis, the environmental footprint of metals is assumed to be constant, as in this table, which shows the LCA values collected from many LCA databases. Unfortunately, this oversimplified solution leads to wrong conclusions because the LCA values of metals depend on following factors: the process technology, metal recoveries, raw materials type, energy efficiencies, energy sources, site location, and recycling rates. For example, the environmental footprint of a laptop is minimal if the laptop is made using sustainable energy sources and metals that have been produced using best available technology and wise recycling methods, compared to a laptop which is made using coal power, energy, and old metal process technology. Unfortunately, this is what consumers cannot know, because these two laptops look quite similar. This illustrates that the environmental footprint of product not only depends on the raw materials used in the product, but also on the process and technologies that produce these raw materials.